Hello everyone, welcome to the new session and welcome to Neet Care Academy. So in this particular session, we are going to discuss a most important topic which may helps both in inorganic as well as organic concepts. Especially this is most important one in order to calculate number of sigma bonds and number of pi bonds as well as stability of a given molecule. Okay, so that is nothing but degree of unsaturation. So you people having complete awareness about this particular topic and see which will be a boosting topic of organic chemistry. Okay, so if you want to understand what is hybridization and how to calculate whether given molecule will participate in chemical reaction or not, that will completely explained by this concept, that is degree of unsaturation. What actually degree of unsaturation will give information and what will be the relation for this degree of unsaturation as well as organic as well as inorganic molecules. So first, what is degree of unsaturation? Unsaturation, nothing but see, it is also defined as unsatisfaction. So how humans are unsatisfied? In the same way, molecules also get unsatisfied. That is nothing but a unsaturation. Unsaturation, nothing but unsatisfaction. Okay. So generally, if you consider any molecule, so I am taking some molecules. Molecules are generally classified into two types. Only two types of molecules will be there based on their characteristic bonds. Okay, first one is saturated and one more is unsaturated. Two types of bonds are present: saturated bonds, unsaturated bonds. So what are saturated bonds? Saturated molecules or saturated bonds, nothing but see, here if any molecule carry carbon-carbon single bond in open system, that is called saturated. Okay, and if any molecule carry carbon-carbon double bond or carbon-carbon triple bond, they becomes a unsaturated molecule. So only two types of molecules are present, either saturated in open system, unsaturated in open system. Unsaturated in open system belongs to either double bond or triple bond. You people know about double bond is nothing but alkene, triple bond is nothing but alkyne, and we know very well carbon-carbon single bond is said to be alkane. So alkane is belongs to this particular family. So we can say that alkanes are completely saturated molecule. So every molecule in organic want to become a saturated molecule because they are unsatisfied. Okay. So finally, if you take any unsaturated molecule, either double bond or triple bond, they want to become a saturated molecule. So that is a final intention of any molecule. In order to neglect their unsatisfaction, they can participate in chemical reaction. Once if they participate in chemical reaction, they becomes a saturated molecule. So ultimate target of any unsaturated molecule want to become a saturated. So you have to know about first alkane. What is alkane? In order to understand this topic, you have to know about alkane. So alkanes are generally is a hydrocarbon which carry carbon-carbon single bond. It is a hydrocarbon. Hydrocarbon nothing but molecules having only carbon and hydrogen. They are called hydrocarbons. And especially if you consider alkane, alkane having a general formula CnH2n plus 2. It is a general formula of an alkane. If you want to understand concept of unsaturation, you should be familiar with alkane general formula. You have to remember this formula. This formula will give some additional modifications to give alkene, alkyne, halogen derivatives, alcohols, ethers, etc. All formulas are related to this one only. Okay. So general formula of alkane is CnH2n plus 2. What is N indicates? N indicates number of carbons. And here if you substitute this N over here, that will give even hydrogens. Suppose see, if I write N is equal to 1, so you may expect CH4, carbon and hydrogen. N is equal to 2, then C, you'll expect C2H6. N is equal to 3, then C, this is C3 and this is H8. N is equal to 4, C4, H10, etc. So like that, if you keep on increasing number N, you will get a hydrocarbon which is said to be a saturate. Saturate nothing but carbon having only single bonds. That molecules are highly stable. They won't involve in any chemical reaction. So I can say that all saturated molecules already they are satisfied. They are not showing any kind of interest to participate in chemical reaction. So that's why saturated molecules are highly inert in chemical reactions. So we are worried about only unsaturated. So that's why alkenes having many chemical reactions, alkane also having many chemical reactions as compared to alkane. So alkanes generally, if I substitute in this formula, we are getting this kind of small units. They are called molecular formula. They are called general formula. So this all having same general formula, all will satisfy same general formula, but all not having same molecular formula. So I can say it is a saturated carbon. It is a saturated molecule with 1 carbon, saturated molecule with 2 carbon, 3 and 4. So in all these cases, what you observed, a common thing. Common thing is carbon carry 4 hydrogens and all single bonds. That is a structure. And if you take C2H6, carbon having this kind of structure, see, here tetrahedral geometry, and you can also write one more tetrahedral geometry over here now. See, this is ethane. Like that we can take C3H8, C4H10 like that. So regularly if you keep on progressing, you will get a saturated molecule in which carbon carry single bond itself. Okay. Now, if you go through next step, now see, so if you see the difference between this unit to this unit, there is only CH2 is differ, and from here also same. And if you compare these two from here to here, there is only CH2 is differ, and here also same, CH2 unit is differ. Same general formula but differ in their molecular formula, and they are differ by only CH2 unit. That is called homologous series. Writing this continuously with increasing number of carbons, that set is nothing but a homologous series, and every individual unit is known as a homolog. So this is a homologous series writing continuously, and this all having a same general formula, and this is called homologous series, and this unit is known as a homolog. Okay. Now I would like to say that suppose carbon having C2H6 molecular formula, this is generally an alkane. Okay. Now I am writing one more unit, C2H4, then followed by C2H2 you write down. Now what is the common thing which you observed if you start with an alkane? See, C2H6 is nothing but an alkane. This is an alkane. Now if you remove 2 hydrogens from alkane, see this, C2H6 is alkane or not? Yes. If you remove 2 hydrogens from alkane, now you will get a alkene, one double bond. Now here if you remove 2 more hydrogens, then what happens? You may get alkyne. There is a simple technique to identify a hydrocarbon with reducing number of hydrogens. That is responsible to give 2 unsaturated molecule and 1 saturated molecule. Right? Now go through one more example. C3 and I am writing H8. Now I am saying it is an alkane. Then how to write its corresponding alkene partner? Alkane partner. Remove 2 hydrogens. C3H6, then followed by C3H4. So here see, number of hydrogens are reduced here. 8 hydrogens, 6 hydrogens and 4. Regularly 2 hydrogens are getting decreased over here. So I can say it is a alkane. Alkane means, see, we can say propane, ane. And here it is propene, ene. Ene nothing but alkene. Then followed by propine. So it is a homologous series of alkene. It is a homologous series of alkane. Regularly see, 2 carbon, now 3 carbon. CH2, CH4. Means here also same case, you observe 2 hydrogens are get differ with 1 carbon. Okay. Suppose if I take one more, C4H10 I am writing. Then in this case, C4H8, then C4H6 you will get. So this is called butene. This is butane and this is butene, and this is called butane. Ine means triple bond. If you observe clearly from here to here, the common difference in this all alkanes is general formula is remain same but differ only in number of carbons and hydrogens. Okay, and here also what is the difference? CH2 CH2. Here also CH2 CH2. But only thing is, if you see the general formula of this one, Cn H2n plus 2, and in this case it is Cn H2n, and in this case the general formula is Cn H2n minus 2. So the degree of unsaturation can helps to determine how much it is unsatisfied. Now if you compare the alkanes, same number of carbons but differ in their hydrogens. And if you see the differ between these two, how many hydrogens are less here? 2 hydrogens if I remove, you will get this one. And if you compare from alkane to alkyne, if I remove 4 hydrogens, Okay. If I remove this hydrogen, here if I remove 4 hydrogens, means I would like to multiply with 2. So 2 into 2, 4. 6 minus 4, you will get 2. Every alkane, if you compare with their corresponding alkane general formula, how many hydrogens are less than alkane general formula? That is called degree of unsaturation. That is a clear term, clear definition of a degree of unsaturation. Suppose here 2 carbons are there. So in this molecule, how many hydrogens are less than alkane general formula? In this molecule, 2 hydrogens are less than alkane general formula. In this molecule, 4 hydrogens are less than alkane formula. Every time we need to compare with a saturated molecule so that it will give a saturated skeleton. So how many hydrogens are less than in this one if these 2 carbons are belongs to alkane? The difference responsible to give degree of unsaturation. Okay. So I will give an example so that you can understand clearly with the degree of unsaturation and how to determine the suitable structure of a given molecule. Right, see, here we can define like this. The number of hydrogens less than alkane general formula. How many hydrogens are less than alkane general formula is called degree of unsaturation. Okay. So the number of hydrogens less than alkane general formula is du. Okay. So is degree of unsaturation. So which means, suppose see, if 2 carbons are there, suppose I given 2 carbons, carbon is 2. So we need to first you substitute in alkane general formula. Then what is the formula? C2H6. We need to substitute these 2 carbons in alkane general formula. Okay, they should carry 6 hydrogens, that is becomes a saturated hydrocarbon. Suppose if 3 carbons are present, then formula is C3H8, and if 4 carbons are present, then formula is C4H10. Now the question is, suppose if they given any new molecule, C2H4 they given, they will give this one and they will ask what is the DU, what is the degree of unsaturation. Now, here 2 carbons are there. If 2 carbons, if you substitute in alkane general formula, how many hydrogens we are getting? And you compare these hydrogens. Now here 6 hydrogens and here 4 hydrogens. So the difference will give degree of unsaturation or ring rule, we can say even. One more name is also there, that is called ring rule. And here also same. Suppose if 3 carbons are there. If 3 carbons, if you substitute in this one, they should carry C3H8. But see, actually, this carry 2 hydrogens. 2 hydrogens are getting for here. 8 hydrogens are there. Here 6 hydrogens are there. And if I take one more, suppose see C3H4, same formula. Now from here to here, how many hydrogens are differ? 4. Okay, that is called degree of unsaturation or degree of unsatisfaction. Suppose see one more, C4H2 I am writing. And if you compare here, 8 hydrogens are there. Number of carbons are remain same. 8 hydrogens, now it is 2 hydrogens. Only 6 hydrogens are get differ. So which means this formula is different, this is different, it is also different. See, from here to here, 2 hydrogens are differ. From here to here, 4. Later on it is 6. Which means every time 2 hydrogens are get differ. So I can say that 2 hydrogens are get differ. Then followed by 4 hydrogens are get differ. 6 hydrogens are get differ. 8 hydrogens we are getting difference. Then 10 hydrogens. Like that we are keep on getting number of hydrogens less than alkane general formula. Suppose if 2 hydrogens are less than alkane general formula, degree of unsaturation is 1. If 4 hydrogens are less than this one, degree of unsaturation is 2. Now it is 3. Now it is 4. Then now it is 5. Like that. So you remember this. This is called DU number, degree of unsaturation. How much it is unsatisfied. If DU number increases, unsatisfaction ability increases. Now it is 5. Now the question is, here 2 carbons responsible to give 6 hydrogens if it is satisfied. But here 2 carbons giving only 4 hydrogens means this molecule is unsatisfied. It is a satisfied molecules and they will give an unsatisfied molecule and they will ask how much they are unsatisfied. So here 2 hydrogens are differ. I can say if 2 hydrogens are differ, degree of unsaturation is 1. Okay, this is called DU number. DU is 1, 2, 3, 4. Okay, so what happens if DU number is fluctuates? Fluctuates by mean degree of unsaturation is 1. What it means actually? So what is the meaning of degree of unsaturation 1? And what is the meaning of degree of unsaturation 2? Okay, if you know this term clearly, you can generate molecules and you can go for identification of isomerism clearly. Okay, so these all structures, all possibilities, all general formulas helps to determine variable structures of a given isomers. and based on that we can write isomerism. So if you know du, concept of isomerism is very easy for you. Okay, next see this. Now see this possibility. Now I am going to give one molecule. Suppose if degree of unsaturation is 1, what it means actually? What is the meaning of degree of unsaturation 1? So already I defined what is du means. How many number of hydrogens are less than alkane general formula? Okay, that is called du. So what actually du1 indicates? Suppose if du1 is getting for any molecule, which means they may carry one double bond or one ring. Any one is possible. You can create one double bond or one ring, depends on number of carbons and hydrogens. Okay, next. Same possibility I am giving. Suppose see if du2 is there, what it means? Degree of unsaturation 2 means you may get 2 double bond or you may get 2 rings, otherwise 1 double bond plus 1 ring. See, every ring indicates 1 du. 1 ring indicates 1 du, 1 double bond 1 du, total 2 du. 2 rings nothing but 2 du, 2 double bond nothing but 2 du. Remember, 1 double bond means 1 pi bond. 1 pi bond gives 1 du. 1 double bond carry 1 pi bond. Okay, now this you will understand by taking example du3 I given. What it means? Degree of unsaturation 3 means 3 double bond, you may get 3 rings, 1 double bond, 2 rings. 1 double bond, 2 rings. Otherwise we can say here 2 double bond, you can write one more. 2 double bond, 1 ring. 2 double bond, 1 ring. And one more, you can write 1 triple bond. Remember, 1 triple bond carry 2 pi bonds. Every pi bond, every ring becomes a du. Here du3 is given. du3 means 3 double bond, 3 rings. It may carry 3 double bond or 3 rings. 1 double bond and 2 ring. And here 2 double bond, 1 ring. And 1 triple bond. 1 triple bond plus, and we can also go through 1 double bond. Otherwise 1 triple bond and 1 ring. 1 triple bond, 1 ring. Like that we can create some selective examples. Remember, between carbon, if pi bond is created, this is sigma and this is pi. Every pi bond is 1 du. Okay? And every ring, see, if I write one ring like this, every ring is 1 du. It should be taken as 1 du. And here every pi bond is 1 du. You remember this point. Okay? Suppose if carbon triple bond is present, here 1 sigma, 2 pi bond is there. How many pi bonds are present? 2 pi bond. 2 pi bond means, here I can say 2 du. 2 pi bond means 2 du. Right? Suppose if I take one ring, this is one ring and I am putting one double bond here. So first we need to consider how many rings are present within this skeleton. This skeleton carry only one ring. Okay, so this is one ring. And any double bonds are present? Yes, one pi bond is present here. You count only pi bonds. Now one pi bond. Otherwise you can say one double bond. One double bond is equal to one pi bond. Now here one ring, one double bond. What is the du of this ring? That ring is 2. So that is this possibility. See here. 2 rings, 2 double bond. Otherwise one ring plus one double bond. Here one ring and one double bond. That is called du. Okay. Now suppose one example I will give with respect to 4 du. This is du4. Now what it means? You may expect 4 double bond, 4 rings, then see 3 double bond plus 1 ring. Many possibilities you can expect. 2 double bonds, then followed by 2 rings, then 1 double bond, 3 rings. 1 double bond, 3 rings. Next we can also consider by taking a triple bond even. Okay, so I can take 2 triple bonds. 2 triple bond. 2 triple bond, every triple bond carry 2 pi. 2 pi means 2 du. Means 2 du, you will get 4. Okay, next we can take 1 triple bond, 2 double bond. Then 1 triple bond, you can take many possibilities. 1 triple bond, then followed by 2 rings. 1 triple bond, 2 rings, like that many possibilities you can take. But ultimately your number will be 4. There is a possibility. Here I usually take in du4, which means these are the possibilities. Not only this, many possibilities will be there. Remember, every DU indicates one pi bond. One DU, one pi bond. Otherwise, if you want to introduce one DU, DU indicates one ring formation. DU means one ring. DU means one pi bond. So pi bond is in double bond. How many pi bonds are there? Only one pi bond. Triple bond, two pi bond, like that. Okay. So this is the possibilities to identify DU of a given possibilities. Okay. So DU for 1, this is a possibility. DU for 2, these are all the possibilities. DU for 4, these are the possibilities. Not only fixed number, you may expect many possible structures are expected here now. So based on this, one can identify the possible structures. Based on that, one can create isomers. If you know DU clearly, you can create isomers of a given molecule. Okay, now I will give an example. You can understand clearly how to determine the structure if DU is given. Suppose if DU is not given, one possibility. If DU is given, what is the possibility? Suppose if they given a formula Cu C2H4I given. C2H4I given. Now, one more formula is there to identify degree of unsaturation directly. Here, 2N1 plus 2 minus N2 by 2. It is one more formula to calculate DU directly. How much degree of unsaturation is there? Okay. So, here N1 indicates number of carbons. N2 indicates number of hydrogens. This is the formula. You can use this formula to calculate the DU number. After that, you can calculate the structure. Now, C2H4. So, substitute this carbon. N1 nothing but number of carbons given in this formula. Hydrogens, you substitute in that formula. So, you can get directly. Now, I am writing 2 into 2 plus 2 minus 4 by 2. 4 by 2. So, finally, 6 minus 4 by 2, 2 by 2. Finally, your answer is what? That is 1. Right? You can substitute in that formula. This 2 indicates number of carbons. This 4 indicates number of hydrogens in a given formula. Now, we are getting 1. What it means? 1 means this formula carry maybe one pi bond or one ring. And simple technique is, if 2 carbons are present, it is possible to create pi bond, but it is impossible to create a ring. So, first you write the possibilities here. 2 carbons you write down. First you write down 2 carbons, then put a single bond. After inserting single bond between them, then write down one more pi bond, because one DU indicates one pi bond. Here one pi bond I introduce. Then balance remaining with hydrogens. Here this carbon carry already 2 bonds, then balance with remaining 2 and balance with remaining 2. Carbon valence is 4. Based on that particular point, I substituted 2 hydrogens here and remaining 2 hydrogens on this side. Now this is the structure of this formula. Only one structure you can create. Okay, so that is end of this particular molecule. Next, go through one more. C3H6 I am writing. C3H6 indicates the number of carbons are 3, then minus 6 by 2. And here also, what is the degree of unsaturation? 8 minus 6 by 2, you will get 2 by 2. 2 by 2 means it is 1. Here also degree of unsaturation 1. So after creating 1, you has to determine that how many carbons are connected in a sequentially. So 1 DU means you can create one double bond or one ring. Now I am writing 3 carbons. You can insert one pi bond in between 2 carbons anywhere between these 2 or these 2. So suppose if I introduce one pi bond here, so now DU is over. I use this formula, I introduce one pi bond based on this DU number. Now it is over. Now then balance with hydrogens. Here already 2 bonds are there, I can balance with 2. Here already 3 bonds are there, balance with 1. And here already one bond is there, balance with 3 hydrogens. Over. DU is over. See, automatically formula matches. C3 and here H6. Formula is over. And see, is it possible to create one ring with the DU? 100% possible. 3 member you can create or not? Remember, write down 3 carbons. This is one more structure. This is first structure with one double bond. Now it is second structure. Now what I am creating is a 3 membered. First, I would like to join 3 carbons. Later on, balance with hydrogen so that carbon carry tetravalency. Now already 2 bonds are connected here. Then write down remaining 2. And here also remain same. Write down remaining 2. And here also remain same. Total C3H6. That is the formula. C3H6 and here also see C3H6. So that's what I would like to say is, if DU is 1, definitely they may carry one pi bond. Okay, first insert one pi bond between any two carbons, then balance with hydrogens such a way that you will get tetravalency, then leave, automatically you will get this formula. And here also same, see, 3 carbons, 6 hydrogen, 2 4 6 etc. So I will give one more so that you will get multiple structure possibilities. So best example is C2H2, calculate du. C2H2, calculate degree of unsaturation. Now same formula I am using now, 2 into 2 plus 2 minus 2 by 2 minus 2 by 2. So 4 plus 2, 6 minus 2 by 2, that is 4 by 2, you will get 2. Degree of unsaturation 2. So what it means, degree of unsaturation 2 means 2 pi bond or 2 rings, or 1 double bond and 1 ring. So with this 2 carbon, first you write down 2 carbons, only 2 carbons are given. We can't create ring, only one possibility. I can insert one pi bond 1 and here one more pi bond over here. So one sigma, how many pi bonds? 2 pi bond. Now here one hydrogen and here one more hydrogen. See, formula is matching. This is the structure. Only one possible structure. We can't create other than this. Because within 2 carbons, impossible to create rings. Minimum 3 carbons are required. Okay? Then see, this is C3H4. One more example I would like to give. C3H4, what is the du? So 2 into 3 plus 2 minus 4 by 2. Okay, 2 into 3, 6 plus 2, 8 minus 4 by 2, you will get 2. Here degree of unsaturation 2. Okay, now write down these 3 carbons here, 1, 2, 3. Here what is the du? 2. 2 means we need to create 2 pi bond. 2 pi bond means here one pi bond, here one more pi bond. It is one molecule. And one more possibility. You can create one pi bond here, one more pi bond here. It is one more possibility. Here total how many pi? 2 pi. And here also 1 pi and here also 1 pi. Here also total 2 pi. Right? Now balance with hydrogens. Here already carbon having 3 bonds, write 1 bond. Here already carbon having 4 bonds, 1 plus 3. So no need to write any hydrogen here. This carbon carry only 1 bond, write down 3 hydrogens. That is the answer. So see this C3H4. Now here also remains same. Carbon carry 2 hydrogens, carbon carry remaining 2. So you can get C3H4, that is the formula. And if you want to apply any ring, you can apply. See this. Write down 3 carbons, 1, 2, 3. Then insert, see, every ring is 1 du. But actually how much you are getting? 2. So which means 2 du we required. Means already one ring I written, then write down any double bond between 2 carbons, anywhere. Suppose if I write one double bond here, now it is balanced. Then here one hydrogen I would like to write, and here you write 2 hydrogens, so that carbon valency becomes 4. Now here write down one more hydrogen. So then formula is C3, 1, 2, 3, 4, C3H4. There is a way of calculating du of a given molecule. Once if you know du, you can create possible isomers. Once if you create these isomers, then it is easy to identify what is chain isomerism, position isomerism, ring chain isomerism, metamerism. So all possible isomers we can create here. Once if you know the concept of isomerism, it is very easy to determine the structures. Okay. Now I will give one more example so that you can understand clearly. Now first you identify what is the du of this particular molecule. See, only just identify the du. One ring, one double bond, du 2. So du is 2. This number indicates du of that particular molecule. Now double bond, du how much? One ring, 2 double bond. Total number is 3. And see, if I write this one, what is the du? Du is 4. One ring, 3 double bond. Okay. Now they are called bicyclic compound. You can determine bicyclic compound like that. 2 rings are there. So 2 du. Degree of unsaturation is 2. Now see, this is a molecule. I am putting one double bond and here one more double bond. 2 rings, 2 double bond. So 2 rings means 2 du. 2 double bond means 2 du. Total how much du? 4. So like that we can determine, by watching the ring, one can easily identify du of a given molecule. You know carbonyl compounds? CH3, C double bond O like this. Here one pi bond is there. One pi bond means 1 du. Okay. Suppose if I take a cyclohexanone, hexanone like that, this is called dienone. Now first you count how many pi bonds are there. Pi bond, and here one more pi bond, and here one more pi bond. Total 4 pi's are there and one ring. 4 plus 1, that is 5, like that. First you count pi bonds, pi, pi, pi and pi, total 4 pi, and one ring is present. So one ring is nothing but 1 du. So 4 plus 1, 5. Okay. So one suitable example I will give so that you need to know about du of that molecule. Du of C6H6. What is the meaning of C6H6? Generally you people are familiar with C6H6. You will think it is benzene. Not only benzene, many isomers are possible with this formula. I will show that one. Du for this one is, see, 2 into 6 plus 2 minus 6 by 2. So 14 minus 6. So generally 2 into 6, 12 plus 2, 14, 14 minus 6. Okay. So that is 8 by 2. 8 by 2 means you will get 4. 4 du. Right. So if du is 4, so what are the possibilities with these 6 carbons? See, 1, 2, 3, 4, 5, 6. Total 6 carbons. So I can introduce one triple bond here. Here one triple bond, here one triple bond. Now here 2 pi and here also 2 pi. Now du is 4, now it is balanced. Now write one hydrogen here, write one hydrogen, and here no hydrogen, here 2 hydrogen, and here also 2 hydrogen. Total becomes C6H6. That is a structure. You can write this triple bond even in middle. Nothing will happen. You can write both in terminal, both are in middle, anywhere, but definitely 4 pi's are required. You can take even 1, 2, 3, 4, 5, 6. Here I am writing one triple bond, and here I am writing one pi, here one pi. See, triple bond means 2 pi, pi bond means 1 pi, and here also 1 pi. Total how many? 4 pi. Now it is get balanced by one hydrogen. Here one hydrogen, here one hydrogen, here one hydrogen, here 2 hydrogen. See, automatically this formula matches. You can take even only double bond. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 carbons. Now see this. Pi bond, then pi bond, pi bond. Now here 1 pi, and here also 1 pi, and here 1 pi, and here also 1 pi. Can I balance with hydrogens here? Can I balance with 2 hydrogens? Now here already 4 bonds are there, no need to add hydrogen. 1 hydrogen we need to add so that you will get 4. And here also 1 hydrogen, and here no hydrogen will be added, and here 2 hydrogen. So C4H6. And go for rings. One of the best example for ring is one ring. How many carbons are present? 6. Every corner is a ring. Every corner in ring is a carbon. Okay. Now here one double bond, double bond, double bond. How many pi bonds are present? 1, 2, 3. 3 pi bond, 6 carbons. Okay. So every corner carry, this carbon carry one hydrogen. One hydrogen, one hydrogen. Total 6 hydrogens are there. So you will get this formula. So benzene is one of the example in this one. Don't think that this C6H6 nothing but only benzene. Many isomers are possible like that. Okay, one more example I will give. See, I would like to create 2 rings. See, this is 4 and here one more. Total how many carbons? 6 carbons. Every ring, here one ring, here one ring. 2 du is over. Now I can create one double bond and here one more double bond. It is one more example. So here it carry one hydrogen, one hydrogen, one hydrogen, 1, 1, 1. That is the formula. And you can also consider like this even. See, 6 carbons are present, then one double bond, then one ring. Then all having same formulas. See, 6 carbons are present, here one ring and here also one more ring. You can create one 5-membered ring and you can also create one adjacent that is responsible to give the structure. See, I am writing one 3-membered, 4, 5, 6. Okay, already one ring is present. 6 carbons are over. Then put one double bond, put one double bond, put one double bond. See this. Here it is pi, pi, and here pi, and one ring. Total 4. Now automatically this formula will matches. Take a 4-membered ring. See this. This is a 4-membered ring. Write to other additional carbons. Here I am writing one carbon, one carbon. Okay. So you need to create du4. If you want to create du4, first you balance 4 carbons. 4 carbons within the ring, 2 more carbons outside of the ring. Total will be 6. Now here I want to write one double bond. Double bond. Now how much du? Pi, pi, ring. Total 3. Now if you put double bond, now see automatically du matches. If du matches, automatically you will get this formula. Now I will give one more example with 5-membered ring. See this. This is a 5-membered ring. Du. First you write down 6 carbons. 5-membered with 6 carbon. 5-membered within the ring. One of the carbon present outside of the ring. So now Du is 1 still. Okay. Now I am putting one double bond here. Then here I am putting one more double bond. Here I am putting one more double bond. Fulvene, fulvalene, calcins, this all are belongs to this case. See, these all examples, if you observe clearly, one common thing is coinciding. That is C6H6. But if I ask you, most of the students, what is C6H6 means, they will say simply benzene. So benzene is not correct, but we can say benzene is at most stable molecule among this all. So that's why that is given in your books, and they given about study of benzene and their chemical reactions, etc. Okay, so that are the possibilities of knowing about the structures. The advantage of learning Du is it will be a boosting topic for concept of isomerism and identifying the variable possible structures. Once if you know how to create the structures without any hesitation, without any balancing the carbons and hydrogens. See, if you know this Du and if you know the technique how to write the pi bonds and rings, no need to calculate number of carbons and hydrogens. Only thing you need to remember whether you are writing this much carbons in a given molecule or not. And by following these generalized rules, one can easily determine the complete structure of a molecule. Once if you know, then see chemical reactions of every organic molecule will be in your fingertips. Okay, so that is about this concept. Hope you people will understand. And in your regular class, this concept will be boosted with more number of examples, so that you people will be one of the strongest areas will be get focused in one respective stream. Okay, so most of the cases Du is one kind of topic which will be a boosting topic for carbonyl compounds, benzene and the derivatives, and even go for carbohydrates, amino acids, like that. So everywhere this topic is going to be followed with you. So that's why you should be very strong in this particular area. Okay, so hopefully you will enjoy this topic, and we are going to come with a new topic in your next session. Thank you for listening this class.